What the heck is a Docker volume and why does it matter? TLDR, persistence. If you want to know what that means or how, that's what we will discuss in this video. This is the fourth video in the Docker Made Easy series. I would recommend you to go through the previous ones, which will help you get a more wholesome understanding of Docker. You will find the links to the previous videos and blogs in the description. Alright, here's what we will discuss today. Firstly, we'll understand what's the problem we are dealing with. Secondly, we'll look at the solution, hint, volumes. Thirdly, we will look at the types of mounts, the differences, and the reasoning behind the preferred choice. Number 4, we will look at the Docker CLI commands to help manage volumes. And number 5, we will look at some other useful persistence topics. Before we get into what volumes are, let's first try to understand what problem they are addressing. Containers by themselves are stateless, meaning the data they contain are lost when the container is recreated. This is because containers only form a thin read-write layer on top of the specified Docker image. And this read-write layer is removed when the container is removed. The details of how images work is further discussed on the second video. This stateless property of a container makes it super lightweight and portable and lets us scale them at will without having to worry much about their underlying storage. But what if we are interested in keeping the container's data beyond its life cycle, like in a stateful application? The classic examples are databases or key value stores. Suppose we need a MongoDB database for our application, so we run a Mongo container like this. Now, if the container was removed, intentionally or unintentionally, we would lose all the data from our MongoDB database. That is probably not what we want. We likely need to store the data in our database persistently, even if the container is lost. So how do we achieve persistence for container data? The solution is mounting. Mounting is the process by which an operating system makes files and directories on a storage device available for its users to access via a file system. By mounting a file or folder from the container's file system to a file or folder on the host's file system, we can ensure that even if the container is removed, the data is persisted. This is because the host would still be available even if the container is removed. There are two primary ways of mounting in Docker to achieve persistence. Number 1, bind mounts, and number 2, volumes. Now mounting might sound confusing if you're new to it. Thankfully, it's pretty straightforward in Docker. No matter which type of mount you decide to use, the data looks the same from within the container. That is, it is exposed as either a directory or a single file within the container's file system. Easy way to visualize the difference between volumes and bind mounts is to think about where the data lives on the Docker host. Bind mounts may be stored anywhere on the host file system, whereas volumes are stored in a particular part of the host file system which is managed by Docker. Additionally, volumes can be of two types: anonymous and named. Name volumes are characterized by a custom name that you provide on creation, which is usually human readable, like these ones. Anonymous volumes are not given an explicit name when they are first created. So Docker gives them a random name, like a hash. Besides the name, both types of volumes behave exactly in the same ways. But named volumes are easier to deal with since you can refer to them using a human readable name. Docker claims that volumes are the best way to persist container data. But why is that so? Even though bind mounts have been around since the early days of Docker, volumes are the preferred form of persistence for most use cases today. The following are the primary reasons for that. Portability. Bind mounts require you to have a specific file system structure in the host, whereas volumes abstract it out because Docker manages it for you. This flexibility with volumes makes your containers much more portable since they are not strongly coupled with the host's file system structure. Security. Since bind mounts can be mounted anywhere on the host, they allow the possibility of giving containers access to sensitive files like system files or directories. This is a big security concern because containers could impact non-Docker processes on the host by modifying those sensitive files. This issue can be avoided by using volumes, which are restricted to a certain part of the file system. Ease of management. Volumes are auto-created and managed by Docker, whereas bind mounts need to be manually mapped to the host's file system. Additionally, you can manage volumes with the Docker CLI, which makes it much more convenient. I/O performance on Docker Desktop. On Docker Desktop, volumes are stored in the Linux virtual machine rather than on the host, which means that the reads and writes have a much lower latency and higher throughput. Accessibility. If you want to store your data on remote servers or cloud providers rather than locally, then volumes are your only choice. Now that we know the why, let's look at the how. Unlike bind mounts, we can manage volumes directly through the Docker CLI. These are the commands that you should be familiar with. To list all volumes, we use the docker volume ls command. To create a volume, we use the docker volume create command along with the name of the volume. To view detailed information about the volume like the creation date, the mount point, or the storage driver, we use the inspect command followed by the name of the volume. To remove a volume, we use the docker volume rm followed by the name of the volume. And we can use the docker volume prune command to remove all the unused local volumes, excluding the ones that are currently being used by containers. Volumes are only removed when you explicitly remove them, not when containers are stopped. Therefore, prune can be a very useful tool in reclaiming unused device storage. Now let's look at how we can solve the MongoDB persistence issue that we had discussed earlier, using both bind mounts and volumes. The idea is simple. We just need to mount the container's file or directory which stores the database state to a volume or bind mount. For the Mongo image, this is the /data/db directory as specified in its Docker Hub documentation. To use bind mounts, we specify the path on the host machine to be mapped to the /data/db directory inside the container. Using anonymous volumes is pretty simple. You don't need to specify anything other than the container's mount file or directory. And Docker automatically creates a new volume with a random name the first time you run it. And named volumes just require you to additionally specify the name of the volume, which in this case we are naming it to Mongo_data. If the named volume doesn't exist locally, it will be created automatically. And that's it. Any of the three solutions can enable persistence, but named volumes would be preferred as we had discussed previously. While we're at it, let's look at two other useful persistence topics: read-only and read-write mounts. Both volumes and bind mounts are read-write by default, meaning containers can both read and modify the data that is mounted from the host. This is usually alright, but sometimes this might not be desired. That is, when we strictly need to give read access to the containers but not write. A mount can be specified to be read only by adding the :ro at the end of the -v option of the Docker run command. Here's an example of a read-only bind mount. And here's the same example using a named volume. Sharing data among multiple containers. Another persistent-related issue is being able to share files or directories among multiple containers. This can be required for many use cases. For example, when running multiple containers of the same service, or for example, when producers and consumers in a distributed system need to share files or something else. Using bind mounts, containers can only share files within a single host or machine, whereas with volumes, containers from many different hosts can share the underlying data. For example, via NFS, S3, or some other storage drivers. This is why volumes are the preferred choice for sharing data among multiple containers. Today, we learned how Docker containers can be made persistent, either by using bind mounts or volumes. We discussed the primary benefits of volumes and learned how we can manage them using the Docker CLI. We also briefly looked at some other useful persistence topics. Docker Compose makes working with volumes easy as a pie. But it's very important to understand the basics of volumes first, which was the goal of this video. If you are interested to learn more about Docker Compose or Docker Swarm, do let me know. If you want to learn more about handling Docker storage, you can check out the official documentation. Links in description. I hope this helps you be a better engineer or DevOps professional. It certainly helps me as I get to learn new things and fill gaps in my own knowledge. Let me know if you have any confusions or suggestions in the comments below. Till then, be bold and keep learning. But most importantly, take care.